everybody. Different change of venue for Dr. D's episode 8. I'm joined with Lee Agostini over here.
Greetings.
Greetings. Green greetings today. We're going to be talking about cancer, development, psychology, and more, all related to the topic of cannabis. As you can definitely see, we have a nice lively picture in the back there with our little pot leaf.
Shout out to our boy Nate, who is our co-host, who couldn't be here today because I think he's sick.
He's got horrible allergies. You gotta love that. So Nate, if you're at home watching, definitely send in some questions for us. I know you're here in spirit.
Actually, cannabis might be good for allergies. I'm not sure. We're not sure yet, even though we've been doing a bunch.
I've got to go through my notes first.
Yeah, we'll let you guys know during the episode how that works out.
Yeah. So just to give you a little bit of what the rundown is, we're going to give you a little background on the history of cannabis, the legal history in the United States in particular, and then we're going to get into a few topics. First, we're going to go into what is a cannabis molecule, what types of cannabis molecules are there, what do they interact with in terms of cannabinoid receptors. Then we'll go into a little bit of detail about what it is they can do in terms of alleviating seizures. In particular, I know we have
there are some certain types of pediatric seizures that we're going to be talking about specifically.
Dravet syndrome and Lennox-Gastaut syndrome. Excuse my
yeah,
French.
and there's also, I'm pretty sure this is pronounced deuce.
Deuce?
It's spelled like goose, but with a D. All my clinical friends out there, please correct me if I'm just butchering these clinical names.
Yeah, please do. We really appreciate that. It's always good to be open to criticism.
Yeah.
And I definitely don't want to be mispronouncing any words here today.
Even though it's going to be filled with.
Oh yeah, it's going to be terrible.
Definitely.
And then we'll go into a little bit of chemotherapeutics. Unfortunately, we won't be able to get into too much with schizophrenia and psychosis. We'll touch briefly, very topically on it. But we do promise a further write-up. We'll be able to put that up on the Dr. D Facebook page, as well as Lee the Scientist.
Oh yeah, as always, for all the followers that are tuning into this episode, follow me on Lee the Scientist on IG. And if you're already following me, please share this because this is going to be packed full of information.
Yeah, it's going to be an extra. It should be a little bit longer than our normal 45 minutes, so please bear with us. After the chemotherapeutics section, where we talk about palliative care and different things like that, we'll go into detail about the anti-tumorigenic properties associated with cannabinoids, and actually, to be honest with you, some pro-tumorigenic properties that cannabinoids.
Yeah, surprisingly.
It just goes to show you that there's no cure for cancer that's going to cure all types of cancers. And I know I've been chomping at the bit to get this out there, but every type of cancer is different, and every subtype of cancer of a type of cancer. So what I mean by that is there's lung cancer, there's colon cancer, which is butt cancer,
yeah.
Prostate cancer, breast cancer.
Is more, yeah. But the point is, cancer is like the term automobile. There's Lexuses, there's Cadillacs, there's
SUVs,
Volvo,
pickup trucks.
Yeah, they're all essentially have four wheels and get you from point A to B. That's what unifies them, but they're so different in so many different ways. And that's why when people ask for cancer cures, they're really talking about something that will probably never exist. Nothing is going to destroy all cancers.
And the term for that is panacea, I believe?
Yeah.
A cure-all. So there's no cure-all for cancer. And we're going to go through a lot of details tonight in the cancer portion where we're going to contradict ourselves a lot, and that's okay, because certain types of cancers, you add a compound A or drug A, it gets rid of that type of cancer.
Right.
And then after giving that compound or drug A for a while, you develop resistance, and then
you select for. Well, we'll get into the specifics of that, but. Yeah. Also, as a disclaimer, the amount of information associated with this topic is
astronomical.
Yeah.
Infinite, if you will.
For two of us to even try to read all of this information and bring you the multitude of facts that we're going to dish out tonight, we would have to do a series on the effects of cannabis. So yeah.
Just bear with us. I know a lot of the things that we're going to be talking about are very important and vital to the field. They're very up to date. However, if you know of some new information or have some sources for us, please throw them in the comments section, and we'll definitely check them out. I do know that we didn't get a chance to look at any of the topical cancer or cannabinoid lotions, and that'll also be part of the post-game write-up. So So how about we get into the heart of the matter, and we start talking about the legal historical context
Right.
of marijuana, cannabis, or weed.
Why is it even a class 1 drug to begin with when we have alcohol on the streets?
Yeah,
Please explain
geez.
this.
Okay.
Please explain this to me.
So we're going to go really briefly, really quickly through this. As you can see, I have a nice little timeline, and this isn't even all the timeline. We have 2 slides of timeline. So let's put it this way. Between 1600s and 1900, domestic production flourished after the Civil War, and basically it was legal.
Yeah.
Thomas Jefferson grew pot, George Washington grew pot, and they used hemp and all the hemp oil products in their daily farming and agricultural needs. So marijuana was definitely used very extensively throughout the United States history, and it's kind of a shame that we go through the next few points where it kind of got tossed to the side and thought of as a cancer, or not a cancer, so to speak. Oh no, why can't I go over here? Oh no. Oh no, bad computer. There we go. All right. Jeez. Can't wait for that new computer next week. All right. So, during the 19th century, hashish became a fad in France and also to some extent in the United States. So people were smoking this in the 1800s. So,
Yeah.
1906 required labeling of any cannabis contained in over-the-counter remedies. So basically, you could go into your local pharmacy and buy cannabis, drink, and gulp it down and feel flying high. It was thought of as just like cocaine and heroin and all these different types of drugs back then.
Which
that
all
they were using.
originate from plants. Cocaine actually comes from the cocoa leaf, cocoa leaf.
Heroin comes from the
Poppy
poppy
seeds,
seed.
yeah.
So all these things were synthesized back then and thought to alleviate human suffering, but there was an epidemic, and actually that's when different narcotic agencies were established throughout the United States, and we'll come back to the uniform, we'll come back to those narcotic agencies soon under Anslinger. 1910 to 1920, after the Mexican Revolution of 1910, immigrants actually flooded into the U.S. to escape the war, and with them they brought the recreational use of the marijuana leaf. And it was ever since then that the pot leaf was associated with Mexican immigrants. And we'll see why that has such a negative connotation coming up in the 1930s.
Well, it's actually interesting giving the historical context with immigrants, especially
nowadays.
Yeah, nowadays how immigrant is almost like a slanderous term, so to speak. There's always been a type of us against them mentality.
Of course.
And with that, we demonize things that are associated with culture. Marijuana being one of them.
And you know, you can see on the slide behind me, I have the Mexican immigrant scourge, and that's what it was. That was what it was deemed. And you know, during the 1930s, the Great Depression hit. You know, 1929, and the Great Fear campaign began, and they associated violence and criminal deviant behavior, and basically they said the racially inferior class was committing these atrocities, basically because they were smoking reefer.
Yeah.
And
Hence the term reefer madness.
yep, which became a blockbuster hit in 1936. And actually, during that point in time, 1932, the Federal Bureau of Narcotics actually strongly encouraged state governments to pass the Uniform State Narcotic Act, which I believe 29 states had outlawed marijuana with that. And basically because of that, you had this backlash where pot is bad, and then you had, you know, reefer madness come out, and then basically New York Academy of Medicine in 1944, LaGuardia report, finds marijuana less dangerous than other drugs and alcohol.
Well,
So,
it's, yeah,
go
I mean,
figure.
this is kind of like something that happens in the U.S. We like to inhibit things. I remember the entire Prohibition period. So this isn't surprising that this occurred this way, but more importantly, it's that these actions, these previous actions, how they affect today's market for marijuana use, medicinally or recreational use. So with that, let's continue with the history and start getting into some of the physiological functions of cannabis.
Yeah, so real quick, there was hemp for victory during World War II, where the U.S. Department of Agriculture actually passed out hemp seeds to give to farmers to grow hemp products because they need it for parachutes, rope, and all these different things that you couldn't just get from, wood from trees. So in 1950s, they enacted federal laws which set up the first mandatory sentences for drug-related offenses, 2 to 10 years with a fine of up to $20,000. 1960s, the counterculture began, And the use of the drug became widespread in upper-scale, middle-class white neighborhoods and families and different things like that. So it was more lenient. And
well,
actually,
cocaine, but we won't get to that
until
later.
And then 1970, repeal of most mandatory minimum sentences. Congress repealed most of the mandatory penalties for drug-related offenses. It was widely acknowledged that mandatory minimum sentences of the 1950s had done nothing to eliminate the drug culture that embraced marijuana through the 60s, and that minimum sentences were imposed that were unduly harsh, like what we're going through today.
Yeah.
So there's this flip, bad to good, bad to good, bad to good, and it all depends upon, you got to follow the money, Big Lebowski.
Right.
So
we'll see the same thing happen with crack in the 80s.
So, and moving forward,
even though crack doesn't have any medicinal effects, so
as you
as far as its legal circumstances,
yeah. I don't think. Jesus Christ.
Back to marijuana.
However, cocaine is actually used as an analgesic. And
it's also used in nasal surgeries as well.
Mm-hmm.
Yeah.
Interesting. Yeah. And so one bad product is crack, and then the good flip side of it, But creation of the USDA, Nixon declares war on drugs. Basically, his aide even came out and said that
Nixon.
Yeah, John Ehrlichman. He actually came out and said that they made the war on drugs so they could put down their political opponents. So it's always an ends to a means. And then 1986, mandatory sentences came back, and we know what that has done to a lot of minority cultures in this country. And then 1996, medical use legalized in California, which brings me to...
Shout out to Cali.
Yeah, thank you, California. Recreational use states that are currently now legal to go and smoke, and you can walk down the street, and if a state trooper stops you, you're okay. If a U.S. Marshal stops you, you're not so good.
Yeah. On top of these states, there's also been a large-scale decriminalization in a lot of states.
Philadelphia is decriminalized.
New York City.
New York. I believe Pittsburgh is as well. And New Jersey, I think, is decriminalized up to an eighth of an ounce.
Somebody, one of our youth fact check that, please. Appreciate it.
Mm-hmm. So recreational use states: Alaska, California, Colorado, Oregon, Massachusetts, Nevada, Washington, and then 27 medical use states in the United States. And not all of these are created equal, so to speak, in terms of the law, but they're pretty much, if you have seizures, I know Texas will let you use certain cannabis oils and different things like that. So we're getting to the point where it shouldn't be a Schedule I drug, where it's incredibly difficult to get this compound.
Even for clinical research, university research, dealing with Class 1 substances creates regulatory loops that are unnecessary, especially when we're trying to figure out what are the medicinal uses, what are the physiological effects of this compound. Most medicines, most drugs come from plants.
Yeah.
So
phytochemicals.
Aspirin is from willow bark tree.
Yeah.
One of the most commonly used drugs ever comes from plant. So the idea that we even have to jump through regulatory hoops to study the effects of something is kind of ridiculous.
It's crazy.
Yeah.
But hopefully, Obama, before you get out of office, you can switch that. And shout out to the Dakota Access Pipeline being stopped. Yeah, good job. So throwing that out there since Obama came up. All right. So cannabinoid compounds, what are they? As you can see listed behind me, there are 9 cannabinoid compounds that we listed here. THC is the first one. Cannabinol is and cannabidiol.
Yeah.
Cannabidiol.
Yeah, we're just going to call that CBD going forward.
Those are the main compounds that they're actually doing research on in terms of clinical research, and those are the ones that have been studied the most, I would say.
So just to give a quick overview when we say the word, cannabinoid, this is a class of drugs. Their structure is what dictates them. Their ability to bind to certain receptors is what dictates what falls into this class. And in humans, or in mammals rather, we have something called the endocannabinoid system. And when we use marijuana products, the compounds found in those, they're called phytocannabinoids, affect this endocannabinoid system either by mimicking the effects or regulating some of the downstream effects.
And it should also be stated that there are some synthetic cannabinoid compounds that we'll be talking about as well. That
are on the market currently.
Yep, especially Epidiolex. So
yeah, we're going to get to that one too.
Yeah, that's a very good one. And how Lee had said that structure dictates function. Well, how that works is through the cannabinoid receptor, which is a G-coupled protein receptor that does its primary action through the three G protein subunits, alpha, beta, and gamma.
Right.
Through the G protein, AC, AMP, cyclic AMP, and PKA pathways. And
Right.
that has a diverse set of downstream targets and different things like that. Behind
Mostly
us,
to do with calcium regulation inside of the cell.
whether that's allowing calcium from the extracellular space into the cell or from intracellular reservoirs in the endoplasmic reticulum, which we'll come back when we talk about
So,
anti-tumorigenic
for all of
properties.
the non-science people that are generally interested in talking about marijuana, let me just explain what's going on right here. Pretty much, you have a compound that's found in cannabis that binds to a receptor, a protein that's on the cell surface, and that creates a slew, I like that term, slew of downstream effects that regulate what your cell decides to do. And how that regulation occurs is through these intracellular pathways that create the physiological effects, right? So the reason why people feel high is because THC is binding to a receptor located on your neuron that tells your body to act a certain way.
Yeah, and basically you can consider the receptor the gatekeeper to a castle, and a guy walks up, says, hey, you know, this is the effect I want you to have, or
Right.
go tell your king, blah, blah, blah. And the little subunits of the G protein are your little henchmen that run,
Yeah.
go and tell X, Y, and Z, you know, upper management,
Right.
upper
They
management.
create this cascade of effects that lead to that castle doing something,
Mhm.
whether it be make more castles, create a bigger castle,
Destroy
another
the castle.
It's a bunch of things, and we'll find out, or you'll find out, as we have already found out through the lengthy reading associated with this topic, that cannabis and a slew of all the compounds associated with it create a smorgasbord, another good term,
Nice.
smorgasbord,
A cornucopia.
a cornucopia of physiological effects.
A
that-
bunch of physiological effects.
that create, it's just so widespread.
I think we should also state that CB1, cannabis receptor 1, is located primarily in the brain,
Yeah.
the peripheral nervous system, which is your nerves where you feel in your arms, your legs. It's also located in the area of your gut, where you actually, you know, that's where you get the sensation of not being able to eat or different things like that, or actually getting hungry. So,
Right.
sorry. And also in the reproductive system. I
Yeah.
had no idea that it was actually in the male and female reproductive system, and actually could possibly play a role in that.
So earlier research in like the 80s and 90s discovered that there's two principal receptors, CB1, which primarily has a stronger affinity, meaning that it binds to THC more so than the CB2, which is a different receptor. CBD preferentially binds to the CB2 receptor. But these things are all over your body. CB2 is, well, it was initially discovered to be found on immune cells.
Immune cells. What do you mean by immune cells?
Like T cells and B cells, pretty much the cells of your body that stop you from getting sick.
Yeah, like really sick in
Yeah.
terms of not just a little, like, you know, you get a scrape or anything like that. We're talking flu sick.
Right.
Or, you know, cancer sick.
Yeah.
So let's keep all that in mind that it's everywhere.
Right.
So,
Also on some other tissues we won't get into because the more people research this, the more that they find out the endocannabinoid system and other downstream effectors are located on different cell types.
yeah. So moving forward, we're going to go into seizures and epilepsy. And we're going to talk about two syndromes in particular, and I know that you had a third one as well.
So we have
We have
Check the
DS,
notes here.
Dravet syndrome. We're going to go what the causes, symptoms, and treatments are.
Lennox-Gastaut, and Deuce.
Deuce. Ah.
I'm,
And then
I'm sure I'm mispronouncing that. Please, somebody with a medical degree or a physician assistant or a nurse, call me and teach me how to pronounce this, please. Google was not like informative in the pronunciation of this.
So really quickly, Dravet syndrome is a rare, catastrophic, lifelong form of epilepsy that begins in the first year with frequent and prolonged seizures. Patients with this face a 15 to 20% mortality rate. Basically, if you have an epileptic seizure, you have, over the course of so much time, a year or whatever, you have a 15 to 20% chance of dying. In most cases, Dravet syndrome is not hereditary. It's actually caused by mutated gene for the first time in a single family member.
Right. So we call those de novo mutations, meaning as you inherited my genetics, my child has all of my genes, well, half of my genes and the mother's genes, and for some reason he or she gets a particular mutation in this gene that we didn't give them. So that spontaneous mutation is called a de novo mutation, And that mutation is in a sodium channel receptor.
Yes, SCNA1 gene, resulting
Right.
in a premature stop codon, which makes, so when proteins are made, their blueprint is basically A's, T's, C's, and G's,
Correct.
which certain parts of the cell go, okay, AAA means this type of amino acid.
Right.
And amino acids are like your brick and mortar to making proteins.
Correct.
So when you had a signal that says, whoa, 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 stop, you get a protein that doesn't work quite right.
Right.
And it's called a truncated protein. It actually encodes for a neuronal voltage-gated sodium channel. In mouse models, these loss-of-function mutations have been observed to result in an increase in sodium currents, impaired excitability of the GABAergic interneurons of the hippocampus.
Yeah,
So that's
GABAergic are
basically-
typically inhibitory neurons, if I'm not mistaken.
And the hippocampus is done with, I believe, memory.
Right.
So
how that works, well, in plain English, because I don't know what's up with this
Jeez,
guy,
blah,
Dave,
blah,
and it's
blah,
blew
blah,
our
blah.
minds over here. But in plain English, if you stop inhibitory neurons from function, you get overactivity of other neurons. And that's the principal cause of these seizures.
it's like hitting the gas with no brake.
Yeah, exactly. And in this case, Dravet syndrome in children causes pediatric seizures. Now, there's two other pediatric seizure forms. They don't necessarily have a genetic etiology, meaning how they are created or function. Most of the time, they're diagnosed by symptoms, but physicians and the medical community aren't really sure how these seizures occur in children.
Yeah. So it's basically they begin Lennox-Gastaut, I know, begins before 4 years of age, and it's in a tonic seizure. So it's not atonic, it's tonic. So it causes stiffness.
Right.
So you get really stiff and you seize. And basically, we're going to be talking about GW Pharmaceuticals product Epidiolex.
So
Epidiolex.
let's just, if you're watching the show, then you probably have heard of not the compound, but you've probably heard of Charlotte's Web. Charlotte's Web was a cannabis oil that was given to certain patients that are having pediatric seizures, and most of the claims associated with this were what we call anecdotal, meaning they're self-reported, but that people listened to those, and some pharmaceutical companies started to look into these effects. And GW Pharmaceuticals is one of the ones that are doing clinical trials associated with cannabis oil, specifically CBD compound.
And GW is currently in phase 3 pivotal trials for Epidiolex with two phase 3 trials woo! in Dravet syndrome and 2 in LGS.
Right.
GW has been conducting preclinical research of cannabidiol CBD in epilepsy since 2007, so when I actually graduated high school, that's basically when they started. And they're in double-blind studies, so they're actually going to be the gold standard
Right.
of clinical
Of
trials.
clinical trials,
basically.
yeah. Double-blind, placebo-controlled, meaning some patients don't receive medicine, they have no idea what they're getting, and it's double-blinding, meaning that the physicians that are even giving the medicine don't even know what they're giving. So we're trying to eliminate all forms of bias in these types of studies. These are the gold standard.
And they're giving with the standard of care. So what that means is that whatever drugs that they're giving for Dravet syndrome or LGS is that they're giving these drugs in addition to the drugs that are already on the market that don't have as high of an efficacy as they would like. And I believe it's only, I think, 25 to so many percent. It's so currently it's 25 for Dravet syndrome and 22 for LGS that don't respond to any type of treatment that's on the market right now. And in particular, let's talk about some of the stats on this drug. I know that seizures were decreased on average by an average of 54% in 137 people who completed 12 weeks on this drug. And patients who had DS responded more positively with a 63% decrease in seizures over 3 months.
Yeah.
So that's pretty.
Yeah, it's pretty crazy.
remarkable.
In the first phase 3 trial associated with Epidiolex, 20 micrograms per kilogram per day achieved a median reduction in monthly drop seizures, a median reduction in seizures of 42% compared to a reduction of 17% in patients taking placebo. So it's important to note here that just by being inside of a clinical trial, there's a placebo effect. And the reason why we talk about the placebo effect is because they aren't getting any medicine, but there's a physiological response. And this happens to do with the way your brain interprets treatment. It's actually, we should do a show on placebo effect because it's actually very complicated. But
And maybe
42 versus 17 is a great difference for clinical trial.
Italian, I know Rosa was very interested in the will to live. I know that actually plays a huge role in
And patient outcomes.
Exactly. So that's a pretty remarkable thing what the mind can actually do over the body. So
right.
we'll have to do a show about that. So let's actually, we actually forgot to mention that Epidiolex is a purified 99% oil-based extract of CBD.
Yeah, so it's cannabidiol, CBD.
So basically what that means is, and I know we don't have really a slide for it, however, you know, people eat edibles that are,
right.
you know, in medicinal marijuana shops and different things like that.
Or cannabis oil, which is the same difference. That the reality is that as much as people are advocates for using this drug, it's super important to know that the fact that a pharmaceutical company is producing these compounds and that they're very pure is to the benefit of everyone.
Exactly.
You don't necessarily want to be taking something that's made in someone's garage.
Yeah, like Joe Schmo can make, you know,
yeah.
brownies one day that are exceedingly strong. Let's say
right.
they're 100 milligrams. And then the next time Joe Schmo makes the same batch, same recipe, you know, maybe adds a little bit more sugar, maybe adds a little bit more chocolate, whatever the case may be.
Or a little bit more cannabis.
Or, yeah, and you get 150 milligrams per
right.
dose. And I know that you had presented a paper that I didn't actually get through the whole thing.
Yeah, so we won't cite this study, but pretty much a group of, well, it was a research study done looking at the labeling of some of these edible products in different states and whether or not they were true to the label. More times than not, they're not. They are either underdosed or over. Like there's, you know, it claims that there's more in there than it actually is, or there's actually, they claim that it's less and there actually is more. Either way, it's very hard to produce significant, consistent clinical outcomes when you don't have, you know, good manufacturing practices producing these compounds.
Exactly, and that kind of plays into another myth that's out there that, you know, pharmaceutical companies don't want to get involved in the cannabis industry because, you know, they're not going to be getting money from it. There's this myth and that myth, you know, and that could be said for a certain thing. They're not going to have a huge high profit margin, but it's very easy to make these compounds on a manufacturer level basis and then to actually produce them at a cheap level, but you know that their purity is going to be 99%, yeah. You know, you're not going to have any other cannabinoid compounds in the drug. You're not going to have, you know, THC, which is the psychoactive ingredient in marijuana, that's going to be in the drug for these kids. You don't, and the kids don't necessarily need to get high to feel the effects of the cannabis oil.
And even though in some of these types of seizure diagnoses, there are some mental health issues associated with some of these kids that have these pediatric seizures, and the THC can be beneficial to some of these patients that do have some type of, I want to call mental abnormality because of the physiological things that are happening in their brain that produces these seizures to begin with.
And yeah, that's the other flip side to it is if you give the CBD without the THC, it won't have the ill effects of the THC on development and psychosis and different things like that. Something that we wanted to cover in today's talk, but it was just well without of the scope. We're gonna run really late tonight. So
yeah, pretty much real quick. If you're a child, don't smoke weed because it's going to negatively impact your neurodevelopment.
Yeah, and
that's
why
the summary at this point.
When I never get into a talk about legalization, I'm always 21's a good age. However, the human brain isn't usually done developing until 23 to 25,
right? And
at that point in time, you know, have at it, Hoss, whatever.
Yeah, whatever floats your boat, or
exactly.
in this case, flies your kite.
Yeah.
But
love it. So tell me about this Epidiolex. I know that there were some side effects involved with this.
Yeah, so they're doing a bunch of clinical trials with this stuff, and so the 3 or the 4 main side effects that I wanted to touch on here, they're all greater than 15%. Sleepiness, 21% of patients experience that, obviously.
Yeah, obviously.
Diarrhea, 17% of patients. Possibly because you're drinking an oil, which no one has ever took burger fat and just drink that. You're probably going to have diarrhea as well. This thing is super hydrophobic, meaning that it avoids water, and that is going to change the way it gets absorbed.
And you know what I found really funny about the list that I have? It's decreased appetite, 16%.
Yeah, and that's because the THC is not there. So THC is the predominant agonist associated with being hungry. So we separate these compounds, and you know, I don't know about you, but when I'm really tired, I don't even have the energy to eat sometimes. And these things are probably correlated. 16% of patients decrease appetite on the drug.
And I noticed that 10 people stopped treatment with due to the side effects, although 3 of the people restarted it.
Right.
So maybe about 3 to 4% stopped the whole,
It's always
themselves from the trial.
It's always important to know that side effect profiles are, patient dependent. Everybody's tolerance is different, but statistically speaking, anything greater than 15% is, worth mentioning.
Exactly.
Especially when it's across the board.
Especially when, I have another note, most side effects were described as mild or moderate and went away. So I guess you can get used to drinking oil and poop.
Yeah, yeah. I mean, like if I got to use the bathroom 3 more times per day, but I'm not having a seizure, I'm cool with that.
Yeah, exactly. So it's definitely showing a lot of promise in the seizure and epilepsy field, and I know that they're going to continue to produce new compounds that are more targeted to specific receptors. I know that there's a couple other receptors that the cannabis CBD can actually activate, and one of them is a sodium channel. I just don't have that have it in my notes, so I apologize.
How these things work in the brain is pretty much when the CB2 receptor gets activated by CBD, this changes the way calcium is utilized in neurons, and by changing the way calcium is used in the neurons, that affects its ability to function. So if you decrease calcium inside of a neuron, it actually can't excrete neurotransmitters.
And how we said it was GABAergic, so it's the neurons that actually reduce excitatory, it's inhibitory.
Right.
So by increasing the inhibitory side with cannabinoids, it makes sense that you're going to decrease the amount of seizures that you have. And so
it's also important to mention that even though we understand how these things bind to receptors, what happens after that is still not well understood, even for the clinical trials associated with this stuff.
And we're going to go into a little bit more detail about that with the cancer section, but we're going to bridge the gap between the epilepsy and the seizures with chemotherapeutics. The common usage of the term chemotherapy is used to connotate the use of rather non-specific intracellular poisons, basically, especially related to inhibiting the process of cell division, known as mitosis, and generally excludes agents that more selectively block extracellular growth signals. So basically what that mouthful means is that chemotherapeutics actually target dividing cells. So when cells go from 1 cell to 2 cells to 5 to 8 cells, 16, 32, 64,
they're doctor's number, you name it.
So it basically, every cell needs to replicate its DNA. And what chemotherapeutics usually do is inhibits that pathway or insert something to make it screwed up.
Yeah, it creates damage.
So the cell goes, oh no, pop, and it dies.
So here's an intro to cancer biology. Pretty much cells that are dividing are uniquely at risk for agents that cause DNA damage. And because proliferating cells have this unique risk for DNA damage, they are more likely to be affected by chemotherapy agents. But it's also common that patients lose hair, have gastrointestinal issues, become immunodeficient, because all these cells are normally rapidly dividing. They're not tumor cells, but they are rapidly dividing.
Blood disorders, constipation,
all these things occur,
diarrhea, mouth and throat sores, and it's because the epithelial cells, the cells that line the mucosal pathways and all these things, like Lee had said, rapidly divide.
Yeah, they're constantly being replaced. And because of that, they're affected by chemotherapy agents. And
here's some types of chemotherapy. Alkylating agents, which actually get put into the DNA, such as, I forgot off the top of my head. Oops.
Don't mind us.
Don't mind us. It's alkylating agents. It attaches to the alkyl group of DNA and it screws it all up, and it causes signals to be released that go, oh no. The DNA up here, it's bound together by maybe a 4-ring, what is it? Isol, it's by the T's.
Oh, thymine dimers?
Thymine dimers, yeah.
Oh, I know what you're talking about. Yeah, I forgot though. Don't mind us with having biology brain parts. PhD students, right?
Cancer biology too.
Ultimately, these things promote the DNA damage response that all cells have, and when you promote that pathway, it causes cells to die.
Certain ones actually do, like anti-tumor antibiotics. They are cell cycle specific drugs. So a cell goes through a life cycle, so to speak. It goes through G1 to S, G1, S, G2, mitosis. And certain drugs will target the cell at different stages. And that's why you have certain cells that will live after chemotherapy and certain ones that won't, depending upon what portion of the cell cycle they're in. They also have anti-metabolites, which can affect the folic acid cycle,
right,
like methotrexate or 5-fluorouracil, which 5-fluorouracil is a suicide substrate.
Pretty much when you affect the metabolism of the small molecules that are used to make DNA, pretty much it's like this. If I'm building bricks and I run out of bricks, I shut down production. And in the cell's case, that means death.
Yep. What's called a topoisomerase inhibitor, which is things that cleave the DNA, so DNA gets wound up real nice and tight, and you need to cleave it to make wide open so you can replicate and different things like that. If you have no means to open up the DNA to replicate it, to make more DNA, or to look at the DNA and go, okay, we need to double it, cells die.
Pretty much this is topoisomerases are analogous to enzymes that when you twist a rope up, as you keep twisting it, you create a tension. Well, in DNA, you need to relieve that tension in some fashion. So if you inhibit those things, DNA breaks. Of course, DNA breaks, DNA damage response.
Like a pair of scissors, basically.
Cells death, yeah, essentially. That also put things back together. It's like cut and paste in one function.
So, and then the last one is just miscellaneous anti-neoplastics. And what anti-neoplastics means is anti-cancers,
right,
or anti-cancer cells. So our next slide.
So we got a question. Does that change your DNA?
No.
It doesn't change these medicines don't change your DNA. They cause breaks in the DNA strands, and your body has mechanisms to realize that those things have occurred. And when there is multiple breaks in your DNA, things die. Although there are some chemotherapy agents that can induce mutations.
Yes. And it can actually cause further cancers.
Yeah, it increases your risk for some cancers down the road, even after 5-year survival times. So yes and no with that answer. This is kind of like a nuanced side effect that is possible, but isn't super likely.
So if you damage the DNA enough and you beat back a bunch of cells, and you say, let's say you have 100 cells, and the chemo gets rid of 99 of them, and that last one, it might get resistant to the therapy. Might change the DNA just a little bit, and
right,
you won't be able to target it with the chemotherapy.
This is something called tumor heterogeneity that we won't necessarily get into here, but pretty much you select for that cell that has the ability to withstand whatever onslaught you're producing, and that could form a new tumor or progress the cancer forward. But this is something that's not unique to these medicines. It's just unique to treating cancer in general. There's a chance of killing stuff and then stuff being resistant, and whatever is resistant will repopulate the tumor environment.
So what is
cancer?
cancer?
So before I get to that, we had a comment from one of our medical geniuses out here, Rosa, that wanted to make sure we had the description for tonic and myoclonic seizures down pat. Tonic also causes loss of consciousness, which is what differentiates it from myoclonic seizures.
Okay, interesting. Thanks, Rosa. Appreciate that. So cancer, I got a nice little definition I'll throw at you, and you can
verify
it as you will.
I'll see how it goes.
All right, cancer is a disease characterized by an uncontrolled division of cells and their ability to spread to different parts of the body. This unregulated growth is caused by damage to DNA, resulting in what's called mutations, and defects in the cell cycle, and defects in apoptotic machinery,
right,
or
programmed cell death.
What I call the self-destruct sequence of cells.
Yeah.
So your cells go, oh wow, there's a bunch of damage, we're being attacked by other things, hit the self-destruct button, boom, it blows up, internalizes, and gets cleaned up.
Right. So just to clear up some myths associated with cancer, cancer is not a bacteria, it's not a fungus, it is your cells, your body, that have taken a wrong turn as far as their ability to cooperate with other cells. They are acting on lone survivor mode and proliferating as much as possible.
So basically what he means by that is they get rewired to the point where they just start growing uncontrollably, they mix up all their signals, and they go, oh wow, it's time to grow, time to grow, time to grow.
And that has nothing to do with the alkalinity of your diet. Just to put that out there.
Or the acidity of your diet.
It has nothing to do with that. Drinking alkaline water will not help you not get cancer or cure your cancer.
Although I do like some smart water. Shout out to Glasso.
Yeah.
Vitamin water. You're looking for that deal. So we have some hallmarks of cancer up behind us, and basically, put it this way: all these different hallmarks that are right here, we can target them with certain inhibitors. We're going to target them with different antibodies. We can do a whole slew of different things. However, the problem with our current knowledge base is that if you hit one type of cancer with, say, an anti-angiogenic drug, that may not be good for other types of cancers because they don't need a lot of blood. And what anti-angiogenic means is anti-blood vessel, anti-blood vessel growth, because tumors are a mass that are growing and growing and growing, but what do cells need?
Oxygen.
And nutrients.
Yeah.
You know, think of it like your block of houses. You know, you have a road in front, you take your trash out, you use that road to go get food at the grocery store, you bring it back to your house. You know, with tumor cells, it's like a new development.
Yeah.
It doesn't have a road built into it yet, so it sends out signals for a construction crew to come in and build up a road.
Not to use the term smart, but cancer is at the point where it's like, oh, there's not blood supply here, I'm just going to produce it.
Yeah. And that's the thing, you know, and coming back to the point where there's not one cure-all or catch-all, because certain cancers like a desert environment, and others like a nice, rich, you know, oasis in the desert.
And they're more susceptible to different things. And this is why different therapies work for different cancers.
And that's basically why, you know, you hit one protein in, say, prostate cancer, but if you use that same treatment in breast cancer, you're going to kill your patient rather quick.
And this is why we study cancer biology to begin with. And one of the reasons why, so back to like marijuana, because it's here we're going into
too much generalities.
Right. How does cannabis affect cancer? Let me just say this: there is no amount of cannabis that you're going to smoke that is going to beat your fucking cancer.
I know you've been beat.
I've been waiting to say that. Like there's no blood on this planet that has enough active ingredients that's going to stick with your cancer.
Let me put that into really long-winded words. Cannabinoids are proving to be unique based upon their targeted action on cancer cells and their ability to spare normal cells. Variation in the effects of cannabinoids in different cell lines, we'll talk about cell lines soon, tumor models could be due to the differential expression or difference in numbers of CB1 receptors and CB2 receptors. Overexpression of the receptors may be effective in killing tumors, whereas low or no expression of these receptors can lead to cell proliferation and metastasis because of the suppression of anti-tumor immune response. So basically what that whole slew of stuff means is that you can hit cancer with cannabinoids, but you're going to cause a whole bunch of different types of downstream effects with that. And meaning that you're going to have some anti-tumorigenic effects, but you're also going to have some pro-tumorigenic effects. Meaning you're going to give signals to go, oh crap, we need to die, but some other cells might take that same signal because the rewiring is a little different than the other cell right next to it and go, oh wow, we need to grow. That guy's dying over there. Whoo, we need to grow.
Yeah. So it's also just want to actually go back to a point that you mentioned earlier about pharmaceutical companies and how there's this like belief that they're trying to suppress cures and stuff like that, or they don't inherently want to use cannabis for some, I don't know, reason that people may think. There are actually a few cannabis derivatives already on the market. One of them is something called Marinol. That's the brand name. The generic or the compound name is dronabinol. This is a synthetic THC compound. It's used to treat appetite loss in HIV and AIDS patients, as well as to reduce nausea and vomiting in patients receiving chemotherapy.
It can actually be used as an anti-anxiety and actually for pain inhibition and inhibition of muscle weakness caused by chemotherapeutics.
Right. So there's definitely I think anybody that is on the anti-marijuana side of this argument or this conversation, the data right now, it's cannabis looks like a pretty good drug to use as adjunct to chemotherapy in treating some of the chemotherapy-induced systems. It's hard to argue against this perspective at this point with the data that's out there, especially with there already being approved drugs.
And the whole thing is, it may not cure cancer, it may not cure any subtype of cancer, and all the research that's going into what we're going to discuss in the next 20 minutes is that, we have something that will alleviate suffering, and what's better than to alleviate suffering of the human condition if you're going to just hold it back through propaganda, all these different things that we covered in the history of marijuana in this country.
And this regulatory, red tape essentially for people to utilize this medicine.
Classifying it as a Schedule I drug. So people in states that it is legal still have to worry about, the aspect of the federal government cracking down on these people. And you know, I've seen different documentaries where people are afraid and they feel victimized, or they feel like they're breaking the law, and they don't want to take these types of drugs because, you know, like it has that stigma.
So it's an interesting thing, just to give you like a real world example. Steve Kerr came out, the coach for the Golden State Warriors, came out and said, if you're an NFL player and you're under pain, I'm pretty sure weed is better for your body than Vicodin.
Yeah.
And so how most pain reducing drugs work is that they don't change, they don't fix whatever's causing you pain. They change your perception of pain.
Yeah. They basically go, if there's a big blinding light in front of you, or the sun is very bright, you put on sunglasses to alleviate that type of.
But it doesn't take the sun away.
But it diminishes what's hurting your eyes and
opiates work on something called a mu receptor. They change your perception of pain. And weed, also marijuana, Mary Jane, cannabis, you name it, also has similar physiological effects where they change a person's perception of pain. But yeah, it's criminalized and it's a class 1 drug. So the person that doesn't want to take Vicodin, that is using marijuana, is inherently in trouble for trying to alleviate whatever pain that they have.
Exactly. So picture behind us is a schematic representation of signaling pathways associated with the cannabinoid receptor. You can see that this G-coupled protein receptor, 7 transmembrane, I believe.
Yes.
Yep. So basically that means the cell wall, cell plasma membrane, cell wall, we're not bacteria, has 7 pieces that go up and down throughout it. And on the inside of it has the G-coupled protein receptors, has G proteins, alpha, beta, and gamma subunits, and they all do certain things, and they talk to these downstream signals down here. As you can see, the MAPK kinase pathway is associated with the cannabinoid receptors, which is the mitogenic activated protein kinase family, RAF, ERK, MAP.
Yep.
PI3K, AKT pathway, they're actually activated by this
we'll get into
receptor. And then
that AKT pathway later.
Ceramide,
Ceramide, yeah.
With a phosphoinositol.
So sphingolipid.
Sphingolipid.
Yeah, it's one of those SPGH words. I don't know how many of you have those words in your normal day-to-day lives, but yeah.
Yeah. And then also, we're going to talk about this pathway over here, P8, and how that's regulated with ATF4, CHOP, and then TRIB, TRIB3, and how that is regulating apoptosis.
Just to touch on our live stream going here on Facebook Live, so one of our medically inclined viewers, we were talking about nausea and vomiting and reducing that, she said, so technically it's used for palliative care.
Palliative care, yeah. And basically that means it's just like for the better benefit of the individual, not necessarily to cure anything or to treat anything other than the ill symptoms or ill effects or side effects of any type of drug. Scroll down on that, I think. Oh yeah. Are we good?
Yeah, we're good.
So behind us are just like a really basic overview, and then we'll go into more detail about the anti-tumorigenic properties of cannabinoid oils and cannabis and THC. Basically, cannabinoids suppress uncontrolled cancer growth, sustained angiogenesis, which basically means making blood vessels, like we had said, and metastatic capability. It blocks, it's basically like being down low, keeping somebody from the basket to get the rebound, but it keeps the cells in place where they're actually growing primarily. It's primary tumor site, and basically everyone knows, well, I would hope most people know that when you get metastasis of cancer, that's not a good thing.
Yeah, just to define what that means is that you have a primary tumor. This is where the cancer originated, and metastasis means that that primary tumor is starting to spread to other places. And this is really what, when you hear about stage 3 or stage 4, these stages are associated with the cells that have broken off from that primary tumor and are growing and impeding other areas of your body, right? So lung cancer, for example, there's a high risk of metastasis to the spinal cord.
Yeah, with prostate cancer, it's to the lung, bone, and actually the brain as well.
Right.
And that's the other aspect of cancer that is really difficult to treat, is that every single type of cancer has a different nesting ground in a different part of the body. So that kind of makes it rather difficult to treat in terms of, to prevent it from going to those different spots. And there's a bunch of clinical trials I know, especially for breast cancer, that's actually using a anti-HIV medication that's actually preventing the cells from breast to go from the breast to other parts of the body by saying blocking the, let's say, the scouting cells of
Right.
the tumor that are going through the blood to get into the area that they want to like settle or colonize.
So there's a bunch of mechanisms associated with tumor metastasis. We won't specifically get into them there, but pretty much there's something called EMT, stands for epithelial to mesenchymal transition, and mesenchymal.
Mesenchymal.
Yeah, tomato. So in the biology world, there's a bunch of ways to pronounce mesenchymal, like the way I just said it, or you can say mesenchymal. But ultimately, these cells are one type, and as they turn into a different type, they're more likely to spread. That's a generalized mechanism. The exact molecular aspects we won't get into for this talk, but yeah.
And they're still being elucidated, which means they're being investigated. They're still being looked at. We don't know what all entails what's going on with that.
CAFs and TAFs.
So the three pathways that we're going to talk about with cancer and cannabinoids are increase of ER stress and autophagy, which means the cell is destroying what's called the organelles, which you can think of as little organs. So the body has little organs like the liver, the stomach, the pancreas, that all do different jobs. So the cell has something very similar in what's organelles. So they have the ER, the nucleus, the Golgi, mitochondria, all the different things that do different jobs. And the
When those things
autophagy
break down, we eat them and make new ones.
Yeah, I wish that.
I wish we can do that.
I wish my liver could get that.
Especially after yesterday. But anyhow.
So this will increase apoptosis or cell death, and it'll keep the cells from dividing. And VEG pathway, which is
vascular endothelial growth factor.
Thank you. That's inhibited, and that keeps the blood vessels from reaching the tumor cells. And then MMP2, which is a metalloproteinase, which...
So pretty much when I was talking about that whole EMT transition from tumor to other tumors, metalloproteinases cleave the surrounding proteins that make cells bind together. So as they are operating on the surface of those tumor cells and they separate, that allows them to swim around and go destroy another part of your body.
Yep. So behind us now we have a more in-depth look at what is going on inside the cell. As you can see you can see the cannabinoids get in there like a lock and key, turn the key, and then the receptor sends a signal down into, I guess, SPT. I'm not familiar with that protein, which increases the amount of ceramide, which is that sphingolipid.
Yeah, I don't know what SPT is.
But it increases ER stress, which goes into the P8 pathway. P8 basically is increased, which is related to ER stress. And that increases ATF-CHOP, which therefore increases TRIB3. And TRIB3 blocks AKT and mTOR, which is necessary for cell survival, cell proliferation, and different things like that. In particular, I know that we just studied about BAD.
Yes.
It's a bad protein.
That and the BCL2 family members of apoptotic and proapoptotic compounds, proteins rather.
So if you block AKT, it can't phosphorylate or turn on BAD, and therefore BAD can't go to the mitochondria and activate, I believe, BCL2 or knock down BCL2 and BCL-XL, and then BAX and BAC can do their job and make pores.
Right. So not to just bog you guys down with the apoptotic lingo, there's been, so principally let's switch to debunk, well not debunking, but elucidating what's going on in some of the clinical trials with cancer and cannabis. Now, I frequent the social media spheres, and
me too.
There's a lot of talk about, truthers are like, cannabis kills cancer and they're hiding it in the government. There's only been one clinical trial with cannabis, any cannabis compound rather, in patients, and it was in a brain cancer called recurrent glioblastoma multiforme, which
is one of the worst types of brain cancers that you can actually get.
Yeah.
It doesn't have a very high survival rate at all. I believe it's like 5%.
Yeah, actually, most people die within like 26 weeks associated with this disease, and pretty much what recurrent glioblastoma multiforme is you got a brain tumor. We've tried to cut it out. We have hit it with like Star Trek photon beam radiation, and this damn thing won't die.
It won't.
So
it grows back and it comes back even worse.
Yeah, even more
ever.
aggressive.
So it's basically like hitting it with a Star Trek photon beam, and then the Klingon comes back angrier than ever.
Yeah, it's kind of like, is this the best you have? Yes, and it is.
Yes.
And these patients have horrible clinical outlooks. So in 2006, some physicians were like, hey, we have these 9 patients that have this crazy brain cancer, and we've got some purified THC. Let's see if it has any effect.
So
right?
can you tell us about how they delivered that drug?
All right, so they actually wrote a giant blunt, and all the no, that's not what happened at all. Like I said, there's no amount of smoking that's going to create cancer. What happened is they created a surgical opening in their skull where the tumor was.
They drilled a hole in their head.
They call it a shunt. So they put a shunt in and then delivered THC straight to the tumor in these patients.
So basically, they cut out smoking the blunt and gave the weed right to the brain.
Yeah, they surgically tapped lips to the tumor and let the tumor smoke the blunt. But
however, there was some anti-tumorigenic properties associated with it. They did see some tumor growth that was stopped, but overall,
all these patients died.
Yeah. And there was no double-blind study, so
yeah, there's no placebo effect. This was so this is like a compassionate use thing. This happens all the time in multiple countries, especially the FDA. I mean, in the United States, when you have some incurable, outlandish disease, and we have some drug that we haven't tested on anybody.
Why not?
Yeah, why not? Why not see if it worked, right? What if all 9 patients got this treatment and then we save their lives, right? So with that hope alone, the FDA allows us to do these types of studies. Just to give you some factoids about this clinical trial, because there were some upsides to this study. There were 9 patients enrolled. They all got the standard therapy, like I said before. It didn't work. And the primary goal of the study was to determine the safety of THC administration.
So they weren't looking at whether or not it was anti-tumorigenic. That was a secondary goal. So they were looking at whether or not they could actually give THC to the patients without them actually having ill effects because of the THC, not necessarily trying to cure the cancer.
Right. So, and overall, from this entire 15-page study that I had the pleasure of reading, so you didn't have to, in all patients, the conclusion could be drawn that THC did not promote tumor proliferation nor decrease patient survival. So what that means is it didn't make the tumors grow faster, and it didn't kill them any quicker as if they didn't use it.
Exactly.
So with that said, because of the molecular mechanisms that have been elucidated using these cannabis compounds, 2 of the patients, now the results were all over this place. All 9 patients that respond the same way, some of them had no effect at all. Their tumor went hogshit wild as if it didn't matter. A few patients had some subtle responses in the beginning, and then as it prolonged, they became unresponsive to treatment. 2 patients did show prolonged tumor decrease, but still not enough for them to overcome the disease because the rate of tumor reduction just wasn't fast enough or good enough, or whatever the case may be.
And basically what I'd like to end on is just, just again, to reiterate this whole thing that's out in the sphere of social media and different things like that, is that there is no cure-all to cancer. There's, even with cannabis, the pathway that we described with P8 to TRIB and to AKT and all those fancy-dancy words where, or fancy-dancy proteins where they increase proliferation or decrease this or that. There's the other flip side where it's pro-tumorigenic, where the CB2, where we said on immune cells, the B and T cells, it actually will lead to immunosuppression, which is a fancy term for your immune system, the thing that keeps you healthy and not getting sick.
Doesn't work so great.
Exactly. So they can't go in and kill the cancer cells like they should. So anything you see online where, the cannabis oils cure cancer, that's in a petri dish. And let me tell you,
vitro.
Exactly. And even in the animal models, a mouse is not a human. And different drugs in mice work very, very effectively. However, that's not necessarily what's going to happen in a human. And that's what really gets me is that there's this misinformation that cannabis oil will cure cancer. And that's fine, we need to look at it and research it and go in depth and see what is actually going on with these pathways and to really understand and get to the level of knowledge to go, okay, we need to give it at this point in time with this drug, and at this time with this chemo
dose,
and this radiation
yeah,
with this surgery.
this concentration, all these things are relative,
And you know, if you give to cannabis oils to say a different type of cancer, it might actually make it worse. So when you ever see somebody that says, "Oh, the cure for cancer is hidden away," you just tell them cancer is not just one disease. It's actually hundreds of different diseases. It's like saying that, you know, there's a reason why there's no cure for the flu yet. It's a new disease every year. So think about the flu over the course of 100 years. You get that in 1 year with cancer by itself.
Right.
So I know it's a bit of a stretch of an analogy.
well, it's
but
just think of it like this: you could have one type of cancer, and as that tumor grows, it
That's the
even
other flip
changes
side.
within itself. One tumor cell, once they divide from each other, this tumor cell can have genetic alterations that differ from the other ones. So it's a super complicated thing. It's the reason why students like us are even studying it to begin with, so we can elucidate these subtle differences to build therapies to attack these cancers.
So let's put it this way. You have cancer, I have cancer. You have lung cancer, I have lung cancer. Your lung cancer is A, B, and C. My lung cancer is B, D, and E.
Right.
But we get treatment, yours goes to B, mine goes to E, and all of a sudden I have A and B in E, and then you have
Yeah.
B, D, and A, and X.
There's
and Z.
so there's also an analysis. Most people I hear are familiar with breast cancer. I mean, it's one of the cancers that women, well, of course, women get it mostly, but as far as all cancer is concerned, the rate of having it is high. Have you ever heard of a triple negative breast cancer? These are based off the type of receptors that are on those cancers, and whether you have them or not, that dictates the type of treatment that physicians pursue. Just calling it breast cancer isn't enough to actually give us information about how to treat these things. So saying that this works against cancer is a very broad term that I feel can be dangerous in a sense when somebody is diagnosed with cancer and they say, you know, I'm just going to go smoke these blunts and not go after chemotherapy because I read on Facebook that cannabis cures cancer. So the reason why we're doing this show is to inform you and also to let you know that there are some potential therapeutic things associated with marijuana that are being investigated, and hopefully some therapies can come out of it.
Exactly.
But
So
don't forego medical treatment on some whim or some ideology.
Yeah, and you know, like we had said, it comes down to the fact that I'm devoting my entire life to this. There's a reason why there's thousands of PhDs, master students, non-masters, like just lab technicians that are devoted their whole lives to cancer research. And you know, there's plenty of nonprofits, there's plenty of other organizations that are involved in cancer research that, you know, if there was a cure, everyone would have it. And you know, I know so many people in this field that just want what's best for the human condition. Like I said, they want to relieve suffering. They want to make the world a little better when they leave. And you know, it might not necessarily be the cure for cancer, but maybe a type of cancer.
I got an example for you. Shout out to Texas A&M that is doing research on trying to synthesize synthetic compounds that work on the endocannabinoid system, that work on these receptors. But because marijuana is still a class 1 drug, they're trying to create synthetic versions of these drugs which don't have to go through the that work in the same way.
They're trying to make the K2
right
pharmaceutical grade.
right, exactly. And this is a university trying to look into how cannabis works and all of its good effects. So
all right, a little housekeeping before we leave. I know that we kept you very long tonight, and thank you for sticking with us. Next week, we're going to be talking about stem cell therapies. In particular, we'll look at insulin in the pancreas. I know that that's one thing I want to look at. And then maybe some neurodegeneration and spinal pain. And then anything that Lee comes up with about stem cells that you've wanted to look at, maybe embryonic or potent.
I'll surprise you guys actually.
Yeah, so look for updates this week. We'll inform you with a little short video like I usually do.
Also,
and,
look for the write-up.
Yep, we'll be throwing up a write-up either tomorrow or Tuesday. Give us a little time. I know I want to watch some Walking Dead tonight. I know we have a test on Friday, so gonna definitely have to get some sleep. Also, We'll throw up a new schedule with next week's episode, the following week's episode. I won't be doing a Christmas episode. I'll do a 5-minute short that week on whatever topic you guys want, maybe something that we didn't cover in today's talk.
Right.
And then I will be doing a New Year's Day special. I haven't decided what that topic's going to be, but that might be a little different in terms of format. We might do a little Google Hangouts, something like that, but we'll keep you in the loop. Can you?
Also, for anybody watching, we've been talking about this website for a while, and pretty much we're at the point where we're looking for writers for our website, so please hit us up on Facebook and Instagram if you're interested in writing scientific content.
Yeah, guys, www.bioislifemedia.com. It's not launched just yet. I know this isn't going to have as much reach as everybody. I know you're going to give me that look. But it's not ready yet, but we'll give you more details about it soon. But as Lee said, if you have any type of scientific writing experience or even just writing experience in your field, say fitness field or any type of biological field or nursing field or whatever, please reach out to us. We definitely need some contributors and some knowledgeable authors that can boost up your CV. And if you want to get into teaching, this is definitely a great opportunity. So thank you for joining Dr. D's discussions. Lee, have any last words?
No, so long.
All right, bye-bye.